Welcome to Mr. Sou's Math World. Today we are going to have an advanced version of method of substitution of integration. Please turn to page 6.6 of your worksheet booklet. So in this question, you can see that there are two variables of x inside the integral here. And then if we differentiate x plus 7, you still cannot have some x here, right? So this time we need another skill. But we still use the rule that we used last time, which is we will let the u to be the thing which is more difficult inside the integral. So to start with, let u to be x plus 7 and then differentiate. So you get du equals to x dx. But then you may wonder how to handle. So we can substitute dx to be du over 8, but we still need to handle this one. Don't worry, you have this piece of information to help you, isn't it? So after you let u to be x minus plus 7, that means you can change the subject to use 8. That means x equals to u minus 7 divided by 8. So here it is. So remember, we have to substitute all the x in one time. So we have 2x here and 1 dx. That means we need to substitute 3 objects in one time. Therefore, from the integral here, you will get 4x. So here x equals to u minus 7 divided by x, then 4x equals to u minus 7 divided by 2. Okay, so you have u minus 7 divided by 2. And then d of x is equals to du divided by 8. And at the same time, we need to also handle square root x plus 7. That means u to the power 1 over 2. But it is not the end of the story, right? So let's simplify the integral. Constant terms, put it outside of the integral. And for inside, you can handle this one carefully. So what should we do here? Let's think about it. So I hope you still remember, if you have two terms on the upper part of the fraction, and if you have only one term of the denominator, you can split the fraction by having u divided by u to the power 1 over 2 and also 7 divided by this. Remember to use index law to express 7 u to the power negative 1 over 2, as we are going to use property b to integrate. So what's next? It means we integrate carefully. So you will get 1 over 16 and then 1 over 2, that means 3 over 2. Flip it upside down. And then minus, of course you have 1 over 16 times 7, and then 1 over 2, that means 2 over 1, u to the power 1 over 2, and then plus c. Now remember, c is arbitrary, so you can just keep it here. So you will get 8, that means 24 in the lower part. So u means x plus 7, and then minus, you get 8 also, then you get 8 and then 7 and 8x plus 7. You may use square root sign also. then also plus c. So finally, all these are handled. U goes to x, simplified, so check it again. X here, and then you get the result at last. So the key point of this question is to let a u for the complicated part. After we differentiate, you can substitute it into u again, and substitute all the x into u in one step. Let's move on example 6.10. So in this question, it is very obvious that we need to substitute for the thing in the upper part, right? Lower part. That means let u to be x to the power 4 minus x plus 9. Then differentiate, you get 4x cubed minus 1 dx. So this one is not as hard as the last one, because you can see that 12x cubed minus 3 is 4 times of this one. So you can just substitute all the things in one step. So integrate, you get 4 du. Then divided by u. Then this is 4, you can put it outside, and then you can take log for it. So after that, you can get 4 log x to the power 4 minus x plus 9, and then plus c. So this one is not difficult for many of you, right? Just the new thing is we have the log to be the lower part of the integral. So if you look at the textbook, there will be alternative method for the way to do integration. So how does it work? So you may have a look on the textbook exercise, and then we will use alternative method in the lesson. We will move on to the next video for example 6.11.